Okay, so now what we want to do is we will want to look at the actual analysis of the insurance company question. So here is our question again. They set the rates thinking the average claim was going to be $1,800. They look at 40 claims. The average claim is $1,950. Do they need to raise their rates because they're going to lose money or not? So this says assume the standard deviation of claims is $500 and set R. Remember R, the critical value. We want the 95% confidence. So we want a 5% chance that we're going to get those results just by chance, or a 5% likelihood we're going to get these results by chance. So I'm going to flip over to the other screen here, and I've put in our formula. This is the Z formula. It is in Chapter 8 in your book. It looks like maybe around page 204 or something like that, 204, 205. Okay, so here's our formula. Z is equal to, Z is equal to the mean, which was, what did we have? We thought it was $1,800. We thought it was $1,800. And the mean of the sample that we took was $1,950 divided by sigma, or the standard deviation, which they told us in the problem was $500, by the square root of n. N is the number. So the number of folks in the sample, or claims in the sample in this case, was 40. So we put 40 in there, and then we just do the math. So let's scroll up here. We've got, see, it's going to be equal to 1,800 minus 1,950. So it's going to be 150 over 500 divided by the square root of 40. And the square root of 40, if we do the calculations, is going to be 6.3245. And then we're going to divide. We've got 150 divided, so we've got 500 divided by 6.3245, which is 150 over 79. That equals 1.898. Whoops. So Z, try to get it all on one page here, is equal to 1.898. Now, what does that mean? In order to interpret that, we have to flip to another screen here. We want to look at our bell curve. And here's our bell curve. Our Z-score, if we go down here, here's our Z-score line, correct? And we're going to go over to nearly 2 because we're looking for our critical value. Our critical value is 1.96. Do you remember that? Do you know how I got there? Let me flip back over here. 1.96, because remember here we set alpha to 0.05. In other words, we want 95% surety that we're not getting this result just by chance. So and alpha of 95 is corresponding to a critical value of 1.96. We can look that up in the table if we want to do that. So we're going to flip back over here, and we know that 1.96, here's 2 in our z table. Here is 2 standard deviations. So we're just a hair below that. So we're going to be like right, whoops, maybe just right here at 1.96. So our result then would have to fall above 1.96, and that's what it would look like graphically. But we already know our number based on our calculations, and our number was what? 1.8 something? 1.898. 1.898. So if we know our critical value is 1.96, we have 1.898, which is less than 1.96. So our value is falling right here someplace. It does not fall in this shaded in area, which means we do not reject the null hypothesis, which means that our research hypothesis or our alternative hypothesis was incorrect. And we cannot say to this insurance company, no, you need to go raise your rates because it looks like you're losing money. They may be okay. And that's the answer to this question.